before going into automotive, I was captured by the fact that so far we've been talking about a very sequential process, what we have seen from chart 2 pages before, which is typical for those projects that take years to be developed. I want just to bring the perspective on other industries like pharma or like fast mover consumer goods. Think about iPhones, or think about now this is the season in Europe where they develop anti-flu vaccines. An anti-flu vaccine, it's something, you know which product you need to build, the vaccine, few months before this product must be produced and sold in the pharmacy. It means the sequence of the steps, I would rather call it kind of, I need to take the terminology from software development, the Scrum methodology. You know, the Scrum methodology is using short sprints in order to develop pieces. And if you need to develop a product and the process and the factory for that product in few months, you need already to have many things thought ahead, and then be able to quickly redo a few of the things that are influenced by the type of product that you want to produce. So it's a different approach. It's of course it's always sequenced, and you always need a final investment decision for all, I think, the capital projects. But it's much more faster, and the way that people interact with each other, it's faster as well. In a similar example, even if it's not known for being the fastest time to market industry, is this page. It's automotive. Automotive, it's not known as the fastest time to market industry. It's indeed, if you look at this page, 3 to 4 years to develop a new process or a new car from a concept down to a serial production. At the end of this flow, we call it start of production. The SOP, it's a very well-known acronym in automotive that tells you when you must start rolling out cars out of the production line, and of course in the good quality as expected. What I want to bring your attention to here, it's a few things. First of all, in this type of industry, you develop the product together with the process. In the upper side of this page, you will see vehicle development. So here the vehicle is developed. All the components that need to be assembled are developed as well. There is also a strong involvement of the suppliers for all what are the parts that are not produced in-house. So it's a continuous exchange of informations, and especially the latest informations from the modeling of the product are flowing into the plant design engineers that need to develop the process accordingly. The second thing that you can see on this page on the middle part, it's a start with the so-called macro design. So you develop the factory, the whole factory, first of all, as a collection or a sequence of black boxes. And then you go more and more into the single departments. For instance, you do the paint shop, you do the assembly, and then you go one level more deeper into what's called micro design, and you go down into the design of the single equipment. The good or best practices of the automotive of this world, they will, the more they develop the design of the process, also implement lean methodologies, lean philosophy in it. And it's, for instance, line balancing. It's one of the most important points, balancing among the different departments at the MIDI level, or balancing among different workstations at micro level. This is an important part that allows you not to to waste capacity because one process is waiting the other one. It must be in flow. And this is something that you can define when you define what capacity is needed and therefore at the process development timing. The other thing that they do is they develop also the organization that will need to be implemented to run the factory. It means they will think, just to make an example, do I have a centralized maintenance department, or will I have a maintenance delegate in each production team that is able to do quick troubleshooting and quick repair so that the assembly line is not stopping for a longer time? This, of course, has an implication on the type of workshop that you need to have. If you're going to have a centralized maintenance workshop, it's, of course, some space that you need to provide, and it should be closer to the production areas that are more capital intensive, like the body shop or the paint shop. On the other hand, if you have a delegate of maintenance in each team, then you probably don't need to provide a central space, but rather decentralized areas. One other thing which I think I would like to mention is, because the product is developed together with the process, there will be some uncertainties that you need to consider in terms of contingencies while you are designing your investment. A typical example is once you have a prototype car, you will be able to use that car and do crash tests. And then you will see if that car is able to achieve the aspired rating in NCAP. If that rating is not achieved, you probably need to increase the stiffness of the body, and therefore you need to add in the process some more welding spots. Therefore, the robots need to have some spare capacity for that. In one of my recent projects for a big German automaker, we found out that to consider this contingency in late product changes, there is around 10% of the initial capex. 10%, it's a lot. It's a lot, and the more we push on digital, the more we push on modeling and doing all the analysis upfront, probably the more we will be able to save that contingency that otherwise is going lost. This is my experience on automotive. James, you can take over for the next page on healthcare.
I have one question, something I didn't really think about before as you were going through this. In automotive, you really have two concurrent design efforts. You have to design the vehicle itself, and then you have to design the way it will be built and the factory in which it will be built. How do you think, or how do those two together?
Well, when you design a vehicle, typically you don't start from scratch. It's typically is an evolution of an existing vehicle. Therefore, the macro decisions are taken. The important part is probably maybe 30% of the whole that will be really determined by that specific new development. So it means you must really rely on a lot of standards that are already in place, and they are already well known also by your suppliers, which, let's say, will also be 70% fixed, and they will be customized in the last 30%, if this answers your question.
So compared to that, I think you'll find at least one example of a healthcare stage gate process is relatively simple. I'm thinking through the automotive example. In health, we're starting to more actually design the way we want to operate the facility before we design the physical facility. But we have a long way to go on that. I think car manufacturing is ahead on that. So within the stage gate process that I'm most familiar with in healthcare, we have a fairly simple one. So we have what we call a feasibility stage at the beginning of the project, and that is done. That's really this framing, what this webinar is about. That's in-house. It's done with our project management, our business development, and strategy folks and our finance people. And we look at how big is the building going to be, what services, and then we use more historical cost to come up with a ballpark about what a project will cost and how long it will take to do it. And we have not invested a lot of money outside during that phase. And then we hit, at the end of that phase, if it looks like there's a credible plan, we will ask for funding for what we call a validation study. So that's our first stage gate. If it's not a reasonable project that we can't do on a napkin, we're probably not going to take it farther. If it looks like we can, we'll ask for 1 to 2% of what we think the total project budget is going to be. And we will start what we call a validation phase. So we will hire the main design and construction team that'll be on the project, and we will advance the design and the design phases I talked about a little bit earlier. We will do what we call criteria design, which will be some of what's traditionally schematic, which is the floor plans, and some of what is traditionally design development, which would be more the elevations of the rooms with the equipment in it. So what does the operating room and the patient room look like more specifically? And so at the end of that validation phase, we will produce a pretty heavy report that will have all of the design assumptions. It'll still be an early level set of design. You could not submit it for permit, but it will capture enough of the scope that the design and construction team can really price what it's going to cost and how long it's going to take to finish design, permit, and build it. And at that point, we will take it back to the board and they will fund the entire project at one time. So I know in a lot of healthcare organizations, they will have a stage gate check-in at each phase of design where they'll have to do a major budget update and they'll come back. We've gone away from that approach and gone to a single funding stage gate for the entire project. But then what we do is during the design and permitting phase, we use what we call target value design. It's a lean concept that's becoming more and more popular, where we're continually estimating the project throughout the design phase. So we're not waiting 3 to 6 months for a new set of drawings to come out and then pricing it in a batch. We're continuously estimating. And if it looks like the project is deviating from what we've got funded, we will stop and check back in with leadership. Sometimes it's our key assumptions were wrong in validation about the size of the building as required by code. Sometimes codes will change. Sometimes the business need of the facility will actually change, which means what we validated is not the correct scope anymore. So we'll go back, but we do not have we do not have these, okay, we'll advance the design 6 months, we'll estimate it again and decide if we're going to go forward. And then we'll advance it another 6 months, estimate it and see if we're going to go forward. We look at all of that as that's waste. And often in our world, it costs more money to reduce the scope. By the time you delay the job and redesign the job to remove scope, we will often end up paying more to get less. So within this strategy, it releases a lot of pressure on the team with a single stage gate for final funding. And then the last gate that we have, which is not an official gate for funding, we just send a letter to our CEO right before we start the majority of the construction. So we would consider that in terms used by others, the final investment decision. We may have spent 10% of the project at that point, but once we break ground, physically start moving earth and putting foundations in, we're pretty committed to finish the project based on the entitlements and stuff. There's very uncommon to build half a hospital. In California, you finish no matter what it costs. So we will check in one last time. The only time I've seen a project at this point not go forward is in 2009 with the financial crash. we actually put a couple of jobs on hold for 2 years until the financials improved. So in summary, this is what stage gate process looks like within one healthcare organization. An initial funding for validation, the entire bulk of the funding, and then one last check-in before starting the majority of the cash flow, which is the construction phase.